Welcome to another episode of My Weird Prompts, an AI-generated podcast featuring the random prompts of Daniel Rosehill as answered by a revolving cast of friendly AI characters. Join us for deep dives into AI, technology, and whatever other random thing Daniel finds fascinating today. Subscribe on Spotify or your favorite podcatcher. Now, today's episode.
Good morning, my two favorite AI bots, Herman and Corin. So I have a question for you guys today. Today I have a project for a client which involves editing a video that's about 90 minutes in duration. It's a conference video. And the color in the original video that I'm going to be editing is a little bit off. So I need to do a little bit of white balance correction to it. Now, working locally, I use Kdenlive and sometimes DaVinci for video editing, but generally Kdenlive. My kind of philosophy is I use the least complicated tool for the task, and Kdenlive generally for projects like this where it's just kind of one edit, I find it's a very useful tool. Now, the challenge for editing for this process is that the renders can be very slow when you're rendering out 90 minutes. GPU acceleration is supposed to work, but it kind of sometimes doesn't work with AMD GPU as well, as it's kind of spotty. In any event, recently I've been using services like Modal and RunPod for serverless GPU inference. And to me, that's a much more logical way to go about doing this. My question is, thinking out loud a little bit, is there any workflow or any mechanism for taking a video project in a tool like Kdenlive where I finish the edits? Obviously, to render that into video, the clips are going to have to be uploaded to the rendering environment, in this case, the cloud. So what I need would be something, I guess, like a tool that takes what's on my editing timeline, takes all the elements in my timeline, all the clips, uploads that to the cloud, and then renders it on a really fast A100 or enterprise grade GPU, with the idea that, yeah, the uploading and downloading, or the uploading rather, might be kind of inefficient, but that's not really the bottleneck. The bottleneck is usually I have a pretty good internet connection. The bottleneck is more typically the rendering time on these big jobs. So just curious if there's any kind of bridges, because I don't really like editing video on the cloud. I've never found a cloud native video editor that I really like. So the idea that does appeal to me much more at the moment is cloud rendering, doing my editing locally and the tools that I like, but doing the actual rendering process itself in the cloud, thereby freeing up your local computer and also using much more powerful rendering hardware than you could afford. Anything like that exists? If so, let's go into specific services, approaches, and the connector that would be needed to act as the bridge, as I'm calling it, and I'm sure there's a better name than that for it.
Welcome back to AI Conversations, the show where we unravel the fascinating intersections of artificial intelligence and, well, everything else. Today, Herman, we're diving into a very real-world problem that I think a lot of our listeners, especially those in creative fields, can relate to.
Indeed, corn. It's a classic bottleneck scenario. We're talking about the agonizing wait times for video rendering and how the cloud, specifically with AI accelerated compute, is offering some truly transformative solutions. What most people don't realize is just how much power is now accessible beyond your desktop.
Oh, I can absolutely relate. I mean, who hasn't stared at a progress bar watching it crawl, especially with a long, complex video project? Our listener's scenario is a perfect example, a 90-minute conference video needing some meticulous white balance correction. They're working locally with tools like Kdenlive or DaVinci Resolve, which are fantastic, but when it comes to rendering that 90-minute beast, their local GPU just isn't cutting it.
That's the crux of it. The user specifically mentioned experiencing slow renders, even with GPU acceleration enabled, sometimes inconsistently with an AMD GPU in Kdenlive. This isn't just an inconvenience, it can severely impact project timelines, client satisfaction, and overall creative flow. The local machine, no matter how beefy, often hits its ceiling, especially for professional-grade, long-form content.
Exactly. So the core question is, how can we bridge that gap? How do you keep your comfortable, established local editing workflow, but offload that heavy-duty, time-consuming rendering process to something incredibly powerful in the cloud, like an A100 GPU? It sounds like the best of both worlds, right? Local control, remote muscle.
Precisely. And this is where the power of cloud computing, particularly with advanced GPUs, comes into play. What we're really talking about is elastic compute, bringing massive, specialized hardware online exactly when you need it, and then releasing it when you don't. Think of it as having access to a supercomputer for just a few hours.
Okay, so let's dig into that. Why is local rendering such a persistent bottleneck, even for someone with a decent workstation? I mean, my machine has a pretty good graphics card. Shouldn't that be enough?
That's a great question, Korn, and it touches on several factors. First, even a good consumer-grade GPU, while excellent for gaming or general design, isn't always optimized for the sustained, highly parallel computational demands of professional video rendering. Enterprise-grade GPUs, like NVIDIA's A100s, are designed for data centers, machine learning, and high-performance computing. They have significantly more processing cores, higher memory bandwidth, and specialized tensor cores that accelerate specific tasks, including video encoding and AI-driven processes.
So it's not just about the raw number of cores, but the A-type of cores and how they're optimized.
Exactly. And beyond the hardware, you have software optimization. The user mentioned Kdenlive and issues with AMD GPUs. Video editing software relies heavily on drivers and API integrations, like CUDA for NVIDIA or OpenCLI CM for AMD, to fully leverage GPU power. If the software isn't perfectly optimized for a specific GPU architecture, or if there are driver inconsistencies, you won't get the full performance benefit. This is a common challenge in the open source world, where optimization might lag behind commercial counterparts or specific hardware combinations.
That makes sense. So, my fancy new gaming GPU might be great for blasting aliens, but not necessarily for crunching through hours of 4K footage.
That's a perfect analogy. And for a 90-minute conference video, especially if it's high resolution or has complex effects, that difference in optimization and raw power becomes exponential. It's the difference between a few hours of rendering and potentially a full day or even longer.
Okay, so the local machine hits a wall. The cloud, with its A100s, is the answer. Our listener mentioned using services like Modal and RunPod for serverless GPU inference. What exactly does that mean in the context of video rendering, and how would that work to address their specific need for white balance correction on a long video?
That's where it gets really interesting. Serverless GPU inference generally refers to platforms where you can deploy and run code that leverages GPUs without having to manage the underlying servers. You define your task, the platform provisions the necessary GPU resources, runs your code, and then scales down. For video rendering, it implies a few potential approaches.
So, it's not like I'm logging into a virtual desktop and running Kdenlive there?
Not necessarily. While you could rent a powerful GPU-enabled virtual machine and install Kdenlive on it, which is a valid IaaS or infrastructure as a service, approach serverless or pay-as-platform as a service often means something more programmatic. You're thinking about a workflow where you'd package your rendering instructions and assets, send them to a cloud function or container, which then executes the rendering task.
Okay, so how do you create that bridge from a local Kdenlive project to this powerful cloud rendering environment? The user explicitly states they don't like editing in the cloud and wants to keep their local tools.
This is the core of their request, and it's a very common and practical need. Since direct native cloud rendering plugins for Kdenlive are rare, unlike say for Adobe Premiere Pro or Blackmagic DaVinci Resolve Studio, which have more robust cloud collaboration and render farm integrations, the bridge needs to be a bit more explicit. There are generally two main pathways here. The first is utilizing commercial cloud render farms. Services like Garage Farm, Ranch Computing, or PixelPlow specialize in this. They often provide plugins or dedicated applications that integrate with popular NLEs.
So, for example, if I was using Premiere Pro, I might have a Send a Render Farm button?
Precisely. You'd package your project, upload your media, and the render farm handles the distribution to their fleet of powerful machines. For less common NLEs like Kdenlive, direct plugins might not exist, but these farms often support more generic project file formats or command line rendering. The second pathway, which aligns more closely with their mention of Modal and RunPod, is a custom programmatic approach leveraging cloud compute platforms. This gives you maximum flexibility but requires a bit more technical setup.
This sounds like where the connector comes in, as the user put it.
Teptensily FFNPUDU Xlace Fschreckly Xklalos Semelas D Xlace Biz D Xlace Biz Xlace Lace Sixlace Clenturist Slace Durslin Spinks Xlace Slace Slace Sleswell Isu Xlace Espli would slay would you would guess that you would derv would vex quest vexturst when row would these.
Wow, that's a much more involved process than just hitting a render button on my desktop. But I can see the power in it, so the connector isn't a piece of software I install, but rather a custom script that orchestrates the whole thing?
For Kdenlive specifically, yes, it would largely be a custom script. The script takes the output of your local edit, the EDL XML, and the raw media, effectively recreating the edit instructions for a cloud-based rendering engine. This script, often written in Python, is the bridge that translates your local creative vision into a cloud executable task.
And that script would also handle telling the cloud machine, hey, use that superfast A100 GPU for this white balance correction and rendering, not just the general CPU.
Absolutely. That's a critical part of the script's logic. You'd configure FFmpeg, for instance, to use NVIDIA's NVENC for encoding, or specify CUDA-enabled filters, ensuring the GPU is fully utilized. The cloud platforms like Modal and RunPod handle the provisioning of the A100 itself. Your script just needs to know how to leverage it within its execution environment.
So, thinking about specific services for this, beyond Modal and RunPod, which our listener is already familiar with for inference, what other options exist for this kind of cloud rendering, particularly for something like Kdenlive?
Given the emphasis on local editing with Kdenlive, the options might lean more towards the custom containerized approach or render farms. All major cloud providers, AWS, Google Cloud, Azure, offer powerful GPU instances. You could spin up an EC2 instance with an A100 on AWS, install Docker, set up your container with Kdenlive just if it can run headless for rendering, FFmpeg, and your Python scripts. This requires more sysadmin knowledge, but offers ultimate control. Services like Modal and RunPod abstract away much of that server management, allowing you to focus on the code within your container. For render farms, while they often have...
What about the cost, Herman? An A100 sounds incredibly powerful, but also incredibly expensive. Is this really cost-effective for a single video, even a long one?
That's an excellent point. An A100 GPU instance on a major cloud provider can range from a few dollars to upwards of $30 per hour depending on the region, instance type, and whether it's an on-demand or spot instance. However, the key is the S-speeds. If an A100 can render that 90-minute video in, say, 30 minutes instead of 6 hours on a local machine, the actual compute cost might be surprisingly low, potentially under $15-20. Plus, you're only paying for the compute 20. Render farms often package this into a per frame or per job cost, abstracting the hourly GPU rate and allowing for more predictable budgeting. For a professional delivering a client project, the time saved and the ability to free up their local workstation for other tasks often justifies the cloud rendering cost significantly.
So it's not just about the hourly rate, but the overall project efficiency and opportunity cost of a slow local render. That's a good perspective.
Exactly. And let's not forget the scalability. If you suddenly get 5 of these 90-minute projects, your local machine would grind to a halt. In the cloud, you can theoretically spin up multiple A100 instances and render them all in parallel.
This is truly fascinating, Herman. So, to summarize the practical takeaways for our listener who wants to keep their local Kdenlive editing but use cloud power for rendering, it's either a dedicated render farm service that might accept their EDLXML and media, or a more DIY approach using a cloud platform like Modal or RunPod, where they write a Python script that orchestrates FFmpeg or a headless NLE to recreate the edit and render it using a powerful Gepica, or a headless NLE to recreate the edit and run 100.
That's a perfect encapsulation, Korn. For Kdenlive, the DIY script with FFmpeg is likely the most flexible and achievable bridge. It requires a bit of scripting knowledge, but the payoff in rendering speed and local machine availability is substantial. The primary challenge would be ensuring that all the specific effects and corrections, including white balance, are accurately translated from the Kdenlive project into FFmpeg commands or parameters for the cloud renderer.
And what about that white balance correction itself? Can FFmpeg handle that with precision, or would that be a more complex part of the script?
FFmpeg has powerful color correction filters, including white balance adjustments. The challenge isn't whether it can't do it, but how accurately the parameters from Kdenlive's interface can be mapped to FFmpeg's command line arguments. This might involve a little trial and error, or even custom logic in the Python script to interpret Kdenlive's specific color correction values. But conceptually, it's entirely feasible.
This is incredible. It really highlights how creative workflows are evolving, moving from purely local to these hybrid models. It's like having a miniature Hollywood post-production studio in your pocket, or at least a click away.
The shift is undeniable. We're moving towards a future where the local machine becomes the interface for creativity, while the heavy lifting happens on demand in massively scalable cloud infrastructure. I predict we'll see even more seamless integrations directly within NLEs in the coming years, making these bridges less custom and more plug-and-play. Imagine AI tools directly assisting with the cloud rendering process, optimizing encoding settings, or even intelligently distributing render tasks.
The idea of my local machine being freed up to start the next project, while the current one is rendering at lightning speed in the cloud, that's a game changer for productivity and creative output. It's not just about speed, it's about workflow efficiency and empowering creators.
Absolutely. The question that remains, of course, is how accessible and intuitive these custom solutions become for the average creator. But for those willing to learn a little scripting, the power is already there.
Fascinating stuff, Herman. This has been an incredibly insightful look into cloud-accelerated video rendering. Thank you for breaking it down for us.
My pleasure, Korn. It's a field that's only going to grow in importance.
And to our listeners, thank you for joining us on AI Conversations. If you're tired of staring at those rendering progress bars, perhaps it's time to look up to the cloud. We'll be back next time with more intriguing discussions.
Until then, keep creating.
Thanks for listening to another episode of My Weird Prompts, an AI-generated podcast featuring Daniel Rosehill's AI prompts, as answered by a revolving cast of friendly AI characters including me, Cornelius the Sloth. Subscribe on Spotify or visit myweirdprompts.com.